Okay, so looking at the integral test, and I'm going to do 1 over the root of x. So first thing I'm going to look at is I'm going to look at the integral. So I want the integral, I'm going to look at the integral between 1 and infinity of 1 over root x dx. So that's the same as x to the minus a half dx. It's between 1 and infinity. So obviously I can integrate that. I'll get add 1 to the power, I get x to the half, and divide by the power, I get 2 x to the half. Let me just differentiate that just to make sure. So I'll get x to the minus a half times a half. Yeah, it should work. So that's between infinity and 1, and so that's equal to, just getting the notation right, so the limit as b goes to infinity of 2b to the half minus the x to the 1 to the half is 1 times 2, so that's 2. But that's really unimportant because basically as b goes to infinity, the square root of infinity is infinity as well, 2 times that, so the limit does not exist. So basically what we're saying is that if I go from 1 all the way here, that area just keeps getting bigger. Yeah, so the area, the limit of the area does not exist. It keeps going on forever and ever and gets bigger and bigger and bigger. And yeah, no problem. And doesn't go to a limit. Yeah. So now we can look at what that means as far as the integral test is concerned. So what we're going to do is we're going to take bars, and each one of these bars is bigger than the area. The first bar is at 1, so I've got 1 plus, because if I put 1 in, I get 1 over the square root of 1, which is 1. The next bar is 1 over root 2, so this bar, put 2 in, I get 1 over root 2. The next bar, 1 over root 3, and so on. So this obviously is the sum, n goes to infinity, n is 1 as 1 over root n. So there we've got that. We can see that the bars are bigger than the area. Therefore, by the integral test, this diverges, because the integral test, by doing the integration, we know that there's no limit for the area under the curve. The bars are bigger than that area, therefore that does diverge. Now there's one thing that I haven't explicitly mentioned yet, which is important, and that is that the curve, the graph, is decreasing. Why is that important? Why that's important is because if that wasn't so, then some of the bars that I've drawn might be smaller than the area. So by the fact that it's constantly decreasing does show that every one of the bars is bigger than the area. I hope that makes sense. Now how could I show that it's constantly decreasing? Well, I could just differentiate x to the minus a half. And if I differentiate that, I get minus a half x to the 3 minus 3 over 2. This is always positive, that's negative, so that's less than 0. Therefore it's always decreasing, so therefore I can use the integral test to show that this series is divergent. It's divergent because the orange bars are bigger than the area under the curve. Thank you.